You saw that we denoted this corrected standard deviation by lowercase s. When we have a sample, this is what we use to approximate the true population standard deviation, sigma. We call this the sample standard deviation. But don't get confused with the actual standard deviation of a small data set. For example, let's say we have this data set where n equals 5. To find the standard deviation of this, we would find the mean, which is 3, take each squared deviation from the mean, add up the squared deviations, which is also called the sum of squares, and divide by 5, or n. That's the standard deviation of these 5 values. But if we're using this to approximate a larger population that this sample came from, then we would divide by n minus 1. So then this would be 4 in the denominator if we're trying to estimate the standard deviation of the population. So don't get confused between these two, but it is kind of confusing because this, when we use this formula with n minus 1 in the denominator, is called the sample standard deviation, and it's denoted by lowercase s. So just remember, if you're given a sample and you need to estimate the population standard deviation, you use this formula with n minus 1 in the denominator, making the whole standard deviation slightly bigger. That's a better estimate then of the true population standard deviation, sigma. But if you have a data set and you need to find the standard deviation of that data set, not approximate a population standard deviation, then you divide by n.